In everyday life, you've seen that practically everything follows a discrete set of rules. Things can be stationary. If you do not have enough energy to get to the top of the hill, you're definitely not going to get over the hill, and motion is continuous. However, once things start getting smaller and smaller, physicists figured out that these rules don't apply anymore, and that they needed a new set of rules. And in these set of rules, you can get over a hill without enough energy to get to the top of the hill, things do strange things when you're not looking, and much more. Welcome to the place where you throw intuition out the window. Welcome to quantum mechanics.
Before 1801, people didn't really know what light was until Thomas Young conducted the double-slit experiment, in which he fired light through a board with one hole and a board with two holes and examined the results. He then concluded that light was a wave. However, in 1887, Heinrich Rudolf Hertz discovered the photoelectric effect, where if light hit a metal, it would sometimes release an electron. Upon further study of this, it was found that light behaved like a particle, which seemed to be in contradiction to what was known earlier. It wasn't until 1905 when Einstein proposed light's wave-particle duality, where light is both a wave and a particle and will exhibit wave or particle-like effects depending on what is tested. And later, in 1923, Louis de Broglie proposed that all matter behaves like this, and this fact was later proven to be true, which means that all matter, from electrons to computers to even people, have wave-like qualities. Now the question for physicists was, what was waving? In 1926, Erwin Schrodinger was able to formulate an equation that determined what the wave looked like. However, people still didn't know what it was. It wasn't until later that it was found out that Schrodinger's equation allows you to find the probability density of a particle, which means that high points in the equation meant that the particle was likely to be found there. With this equation, Werner Heisenberg in 1927 was able to formulate his uncertainty principle, where the more certain you are of a particle's momentum, the less certain you are about its position, and vice versa. Another interesting thing you can figure out with Schrodinger's equation is a process called quantum tunneling. It's the process by which a particle can get through an obstacle without having enough energy to get through the obstacle. If you were to graph Schrodinger's equation in this scenario, it would look like this. The part at the end means that the particle has a chance of getting through the obstacle.
In this short video, we have only covered the highlights of quantum mechanics, and there is much more to learn, from quantum entanglement to the wave function collapse, and much more in this counterintuitive world of quantum mechanics.